what is a limit? So I'm going to draw a function. I want to think about what a function looks like. So here's our y-axis and here's our x-axis. And I'm going to throw a function up. And here, let's see, I'm going to have, this is nice and smooth. And then I'm going to throw a corner in, kind of a cuspy corner. And then I'm going to throw a jump. This is a jump discontinuity. You've seen these before, right? All right, so here's a function. This is y equals f of x. And we're going to examine this function in terms of limits. Okay? So let me make, I'm going to put a grid line in green. Okay? And we're going to look at different values. We're going to look at different values of x and explore the limit. Okay? So here's one value of x. I'm making my little, sort of like a crosshair so you can find its location. I'm going to move this up. This is going to be my first x value that we're going to investigate. And so what I'm going to do is I'm going to call this x value a. Okay? Now I'm going to give it another x value. And let's see, let's do one, at our, this is actually really, I called this a corner. It's more of a cusp because there's a little bit of curvature there. And so let me get the height of that. Let me move that down a little bit. So this is B is at our little bit of a sort of cornery cusp. So we're going to investigate the limit as x approaches A, the limit as x approaches B, and then we're going to have the limit as x approaches C. That's our jump discontinuity. And so let me throw in C. Okay. You can see that it exists at one height but not the other. Since it exists at one height but not the other, if I do my horizontal to find the crosshairs, I really need two. Hopefully this is not going to get too busy. There's one here, right? And in fact, probably, well, I'll go ahead and put it there, but the function doesn't exist at that point. Hopefully you can see that there's a hole right there, right? Let me just draw it in red to emphasize the fact that at this point, there's a hole, okay? And I need to put in one more crosshair, and that is, well, there is a hole at x equals b, however, there's also, there's a hole at x equals b at that height, but not at this height, so it actually exists here. I guess these are one on top of the other. Same height. Okay, so let's go ahead and let me label the y-axis in black. Okay, so this point right here is f of c. It's also f of b, isn't it? So I'll say that this first point is, I have to use a smaller font. Hold on. This is f of b. It's also f of c. Okay, because b and c have the same height. When x is b and x is c, we have the same height. Then let's see, this next one up doesn't actually exist. There's a hole there. So I'm going to say it's some y value. We'll call it d, because it's not, it actually doesn't, that height doesn't exist for the function at x equals c. And then the top height, that's f of a. So this is f of a. And this is not an A, this is a D. Okay, good. Now let's go ahead, and what we're going to do is we're going to look at the limit. I'm going to shrink this so I can put limits underneath. So I'm going to grab the whole thing. Actually, grab the whole thing and shrink it, because the first thing, I want to look at the limit as x approaches A. So let me resize this. It disappears for just a minute because I'm resizing it. And now it's back. All right, and I'm going to blow it up a little bit. Okay, so now, when we are figuring out a limit, let me just tell you the rule for a limit. Maybe I should put the rule for a limit over here. Here's the rule for a limit. Okay, We have a left-hand limit and a right-hand limit, okay? So if, and I'm going to do a little, let me do a little mini diagram here just to do like your standard example of what a limit is, and I'm going to throw a curve in like this, okay? And in this one, I'm going to do little crosshairs, and this is explaining a limit, okay? And in this case, we'll say this is f of a, see, that's a, this is f of a, and which is going to be the limit. And okay, for a limit to exist, we say the following: if the limit as x approaches a from the left of our function f of x, and this is f of x. This is our function f of x right here. So what I'm saying is, if the limit exists as x approaches a from the left, that's what that says. It means if I'm coming in and my x value, say x is right here, and x is moving from the left towards a, then what's going on with my function? Well, my function, as x moves towards a, I'm coming in towards the left, and I am approaching a height of f of a, right? So the limit as x approaches a from the left-hand side of this function, the limit is the height that I am approaching. It is the height that I am approaching at the point where I would get to x equals a. I never get there, but what height am I approaching? And in this particular case, actually, I am approaching a height of f of a. And in fact, f of a is the limit. It is the limit, okay? Second, if the limit as x approaches a from the right exists, okay, so now I have to approach a. Now x is on the right-hand side of a, and it's approaching a from the right, which means I'm coming in from the right-hand side, and x is approaching a, which means the height is approaching f of a, right? I never get there, but I'm almost there. So I'm approaching a height of f of a, which means that the limit as x approaches a from the right exists. It's f of a. So f of a is the limit. And as a matter of fact, I'm going to say this is limit 1 and this is limit 2. Okay? They both have a limit. So I'm saying if the limit as x approaches a from the left exists, and if the limit as x approaches a from the right exists, if this is true, and I should just say if this is true and this is true, and one more thing, let me shrink this up a little bit, and also the left-hand limit, limit 1, is equal to the right-hand limit, limit 2. So if it exists from the left and it exists from the right, and the two limits are the same conclusion, then the following is true. Then it is true that the limit as x approaches a, and this is not a right or left-hand limit, this is total, a limit. The limit as x approaches a of f of x exists, and it's actually equal to limit 1 and limit 2. Okay? So in order for a limit to exist, you must approach a height from the left as x approaches a. You must approach a right from the height as from the right as x approaches a. And if you approach the same height from the left and the right, if the limit exists from the left and the right, and it's the same, then the limit exists. Okay? So with that knowledge, we need to discover or determine if the limit exists. Is there a limit as f of x approaches a? Is there a limit, and what is it? Okay? So the first one here is what is the limit as x approaches a of f of x? There's the question. So we have to look at the left-hand limit. As x approaches a from the left, our function is growing to a height of f of a. As x approaches a from the right, the function is growing to a height of f of a. So it's approaching the same height from the left and the right. The limit exists. And in fact, what is the limit? The limit is f of a, because in fact, f of a exists. That is the limit. Okay? Now let's look at the limit as x approaches b for f of x. Well, the limit as x approaches b for f of x, it approaches a height of f of b or f of c. Okay? And in this particular one, let me do the following. I want to pop a hole here. So, because I want to emphasize something. So I'm putting a hole. So it's a cusp with a hole at the tip. Come on, hole. So let's imagine, in fact, that the function f of b actually doesn't exist. So I'm actually going to have to get rid of this, aren't I? And I'm going to call this instead e. Okay, this is a height of e. So coming in from the left, as x approaches from the left-hand side. See, here approaching from the left, here approaching from the right. Here I'm approaching from the left. As I approach from the left, I'm approaching a height of e, right? And as I approach from the right, as x approaches b from the right, I'm approaching a height of e. So the heights I'm approaching are the same. It does not matter that the function doesn't exist, because x never actually equals b in this limit. And since the left-hand height, as x approaches b from the left, the limit is e. As x approaches b from the right, the limit is e. Therefore, they're both e. They are equal to the same thing, so the limit as x approaches b exists, and it's e. Now, notice the difference here is that the first limit as x approaches a, the function actually exists there. But in the second limit, as x approaches b, the function actually doesn't exist there, but the limit does. Okay? Now, if we look at this next one, as x approaches c, we're approaching a height of d. It doesn't matter that the function doesn't exist. So, as x approaches c from the left-hand side, the left-hand limit exists, and it's d. As x approaches c from the right-hand side, it approaches a height of e. The right-hand limit exists. However, the left and the right-hand limits are not the same. They both exist, but they're not the same. So in this particular case, we say the limit as x approaches c of f of x does not exist. Does not exist. And the reason it does not exist is because the left-hand, although the left-hand and the right-hand limit exist, they are not the same. And it must satisfy three criteria. Again, for a limit to exist, the right-hand limit has to exist. Excuse me, that's the left-hand. The left-hand limit has to exist, the right-hand limit has to exist, and the left and right-hand limit must be equal. And if that is true, then we say that the overall limit exists.